Hey folks, welcome back to another video. Today we're looking at question 576, out of boundary paths. The way we'll be approaching this problem is by using dynamic programming, and we'll use a DP array to keep a track of the number of ways you can possibly get to a particular position. So let's set that up and we can walk through the solution. First thing that we need to do is set up the array. Let's do that. So to the array of size m and n, since that's given to us. Next up, the first thing that we want to do is actually set the initial value. So we have the starting cell, like the start row and the start column, which I've just changed to x and y for simplicity. So let's assign that to be 1, which basically means that there's one way of getting to that particular cell, since that's the place we're actually starting at. Other two variables that we want to take care of, the result that will initially do 0, and then the other one that you want to take care of is the modulus. So it will be the value that here, modulo, so that would be to the power of 9, 3, 6, 9 zeros plus 7. Let me double check that. 3 and 3 and 3. Awesome, cool. So we'll have a for loop here, and we will be going through the for loop for the number of moves that we have. So for every single move, we want to check, hey, where has the football been before, and if the football is at a particular position, how many other cells can it go to? So you need to do that. The number of moves, you need to do that max move time. So you'll assign, like, let's actually start with k equals 1, k less than or equal to max move, and increment k. Right, and then once all of it is done, you want to return results. So this is the initial setup. So let's jump right in. So the DP array that you have right here, that will keep a track of how many ways there are to get to a particular cell at the previous stage. But at a given stage, you need to be able to see, with the previous position that the ball was at, how many new positions can it possibly take? So being able to keep a track of the number of times it's been seen before in the previous move and the number of times it's being seen in the current move, they're different, and to be able to keep a track of that, you need another temp array. So let's initialize that. So let me quickly iterate through that again. The reason why we have two different DP arrays is because this particular DP array will keep a track of the number of ways you can get to a particular cell in the previous move, and the temp array that we see right here will keep a track of the number of ways you can get to a current cell in the current move. And since you don't want to mix up the previous and the current, that's the reason why we have two different arrays. So since we'll be walking through every single cell. So let's write the for loops for that. So I equals 0, I less than m, and increment I, and then you'll iterate through every single row with the I variable, and then you want to iterate through every single column with the j variable. And then once you're done with both of these for loops, you want to assign the old the temp array that you have to be DP, because once you've finished this particular loop, we need a new loop, and DP, since it represents the moves that we've seen in the previous move, so that's the reason you're reassigning it. So once you've done all the computation in these two for loops, you need to reassign that. Perfect. So once we are inside these two for loops, we need to check that, hey, for the current position that we are at, can we actually leave the boundary? So if I equals 0, which means it's at the top row, it could possibly, like right here you see it's on the top row, so there are ways of actually like leaving the boundary. So that's when you need to update your result. So result would be equal to res plus dp of I plus j. and then you want to mod that as well, just to keep the results clean, since the numbers could exceed that. So you're checking that for the top row, and you need to do that for all of the side rows and columns. So we have to do that 4 times, right? So the top row, bottom row, leftmost column, and the rightmost column. So let's set that up. So I equals m minus 1, and if j equals 0, or j equals n minus 1. Since all of these are the test conditions for actually leaving the boundary, you will look at, hey, like, listen, like, okay, since it could possibly leave the boundaries, how many particular ways are there to actually get at that, which you've reached at the previous level, and you're adding that to the result and modding it. Awesome. So once you've actually updated the ways you're actually leaving the grid, what you need to calculate is that how many ways you can actually, so what are the number of cells that you can get to from that particular cell that you're looking at. So what does that look like? So let's say you want to initialize the current cell value to be 0, and then you're looking in 4 directions, right? Top, bottom, right, and left. So let's do that. So it would be current value would be equal to, if I is greater than 0, you would say get dp of I minus 1 and j, or you would just add 0. So what is it looking at? It's just looking at the cell to its left. It's saying, hey, like, if you can actually move to the left, do that, and then now you want to look to the right as well. Yeah, so let's do that. So, but here you're not checking for 0, you're checking for the other condition, which is less than m minus 1, right? So +1. Oh, so this is like top and bottom, sorry. So this, since this is I, you're looking at the top and the bottom, and then once you're adding both of these, you would just mod it, and you would want to do the same for this one as well. Whoops. Right. So let's do that. So this would be j, I minus I and j minus 1, and then you would do this as well. Right, and then perfect. Oh, just one thing though, I think this would be, you're not reassigning it, you're just adding back to it. Okay, I think this should be okay, so let's quickly run this and see if it's okay. Why? If, oh, right here. So let's do that again. Where could I have gone wrong? So let's go to the for loop for I equals 0, I less than m. This looks okay. This looks okay as well. If res is equal to res plus, okay, I is equal to j. Okay, cool. This still looks okay. And then you have, oh, you need to reassign the value. So once you have that, you say temp of I of j. So you have that, but you just need to reassign it, of course. Okay, now it should be fine. Okay, perfect. Let's submit this and see if it's okay. Mod. And then, like, let's do this. I think whenever the big values are off, it usually makes sense to just mod everything, all of the results that you're adding back. Perfect, so this looks okay as well. Okay, so that was the solution for this problem. Let's talk about the space and the time complexity. The time complexity of the entire solution is m into n into k, because we have 3 for loops here, one for the number of moves, and the other one for m, which is the number of rows, and then and the number of columns. So it would be m and k, and the space complexity is O of mn, since we are using a 2D array to store all of our results. Perfect. So if you have any questions, please let me know in the comments below. Please don't forget to subscribe. I would really appreciate that, and I'll see you all in the next video. Peace.